we have to graph the log base 3 of x plus 1. The first thing to understand is what your basic log function graph looks like. So I'm going to draw in my x-axis and my y-axis. And the main thing with this, so this is 1 right here. If you want to look at, what you need to do is look at your basic function, which would be the log base 3 of x in this case. Okay, and let's think about what that would look like. It's always good to kind of understand what it is that we're doing. So if I plug in 1 for x, what's the log base 3 of 1?
Log base 3 of 1 is 3.
No,
3,
it's
sorry.
0.
It's 0, yeah.
Yes, because that means 3 to what power equals x, right? That's what that means. Or 3
Yeah.
to what power equals 1. And
All
the
right.
answer is 0. So I'm gonna very carefully choose numbers to put in here. Notice what I'm doing. I'm gonna choose 3. Now I'm gonna plug in 3. So first of all, let's plot that point. So there's my first point. And if I choose 3 for x, notice the reason that I chose 3 is because the log base 3 of 3, that just means 3 to what power equals 3. And of course, the answer to that is
1.
1. Very good. So 3, that point would be there. Got it? The next point I'm going to choose, what do you think the next point I'm going to choose is? The next x value?
9.
Very good. You got the idea, right? So the log base 3 of 9, of course, equals what?
2.
Perfect. So when I get over here to, here's 5, 6, 7, 8, 9, I'm going to be at 2 right there. So that's what the graph is doing. This direction, it's going like this. And it can't be negative. I can't plug negatives in there. But if I plug in, let's say, I don't know, 1/3 power. Why would I choose 1/3 power?
The 1/3 power would be the cube root.
But why did I choose 1/3 instead of, I don't know, 1/5?
So that
what's another way I could write? Yeah, what's another way that I could write the 1/3 power? That's the same as 3 to the -1, isn't it?
Yeah.
And so this is just equal to -1.
Okay.
Got it? So at 1/3, it's -1. So there's another point. And what's it going to be at 1/9, let's say?
1/9 would be -2.
That's right. So do you understand what's going to happen over here? It's going to approach but never reach that line. So that's the general graph, or the standard graph for a logarithmic function. Notice that we have a vertical asymptote, and it's at the y-axis. And notice that it goes off. It's not really exponentially, it's logarithmically. What this really is a flip of that exponential graph that we've had in the past, right? It's a flip of that. So there is that one, right?
Yeah.
So it's a flip over the line y equals x. You understand that? Understand what I mean by that? Okay. So now let's look at what this is over here, what the actual graph that we're trying to graph is. I'm going to do this in, no, I'm not going to use blue. I'll do this in yellow. What's the difference between this graph and the one that I just graphed in red? What does this +2 do to it?
The +2 is going to shift it up a bit too. Or no, it's going to shift
up.
to the left.
Very good. It's going to shift it left 2. Very good. So every one of these points is just going to shift, and the vertical asymptote is going to shift left 2. So your VASI, your vertical asymptote, instead of y equals 0, it's y equals -2.
Yeah.
Whoops, sorry, I wrote that wrong. Not y. X equals -2. Vertical lines are x equals, right? And the domain And the range, the domain is going to be from the domain, I'll write it underneath there. It's from -2, not including it, to infinity, right? And the range is just all real numbers.
Yeah.
Got that? Can you see that? Can you see
Yeah.
what the x-intercept's going to be?
It's -1.
Yeah, remember every point's going to move to the left too. So every one of these points just moves left too. It's, if you've graphed it already, it's pretty easy to see what that graph's going to look like. So the x-intercept is -1. It's -1, 0. And what's the y-intercept?
The Y-intercept is maybe 1/2.
Let's not even say maybe. Let's make an exact estimate for the y-intercept. How do I find the y-intercept again?
Just substitute 0 for x.
That's right. So let's plug in 0 for x, and then our answer would be log base 3 of 2. So that's the actual y-intercept, to be exact.
All right.
Okay, you good with that?
Yeah.
All right, let's try the next one. So what's the difference between this and the one that we just saw? Again, let me draw in a y-axis and an x-axis. What's the difference here? What does this negative right here do to the graph?
Sorry, I'm trying to write something really quick. Okay, the negative is gonna flip it.
Flip it which way?
It's gonna flip it vertically.
Right. So instead of being like this, it's going to be like this, right?
Yeah.
So the point, so let's just do this one step at a time. So that point would be there, and it would be going like that and like this. And what does this +3 do to it?
The +3 shifts it up by 3.
Good. And up by 3 is going to mean it's going to go right. So the point that was at 1, 0 is going to be at 1, 3.
Yeah.
Right? And it's still going to be approaching like this. And that point, remember, we normally would have gone over, what do we say, 3 over to 3 and then up 1. So that's where
Yeah.
that point is going to be right there. And so the graph's going to do this roughly. Yes?
Yeah.
Sound good? All right. And now one good thing to do is to just check to make sure that that actually worked. So let's plug this point in right here. This point seems like it's 3, 2. Let's make sure that 3, 2 actually works in our function, just to make sure we didn't make a mistake. So plug in 3 here. What's the log base 3 of 3?
Log base 3 of 3 is 1.
Good. And what's -1 plus 3?
-1.
It's 2. So we did
Yeah.
that right. Got it?
Yeah.
All right. So tell me what the domain is.
The domain is the domain is 0, 0, infinity.
Good. What's the range?
Infinity.
Good. Negative infinity to infinity.
Negative infinity.
Good. What's the VASI?
The VASI is approaching 0, so 0. X equals 0.
Perfect. What's the x-intercept?
No x-intercept. Or like you just plug it in.
Will we have an x-intercept?
Because we wrote it as range, the range as -infinity to infinity, so
Mm-hmm. You said no X-intercept, but I think you mean no Y-intercept.
Yeah, no Y-intercept.
So the X-intercept, how do I find the X-intercept again? Let's do the work over here.
You have to have 0 equals negative log base 3 of x.
Perfect,
Oh, it's
good.
actually negative log base 5 of x.
Oh, this is a
Negative,
5, not a 3?
yeah, negative log base 5 of x.
All right, well, we're going to leave it as a 3 for now because I don't want to change it all. I couldn't
Okay.
read exactly on that picture when I transcribed
Sorry.
it. It's not that big of a difference. How would I solve this equation? Do you know how to solve this equation?
You would subtract 3 from both sides.
Perfect. Then what?
Negative log base 5 of x, and then divide both sides by -1, so you get 3 equals log base 5 of x.
Good. And let's just keep it log base 3 of x.
5 to the power of 3 equals x.
Mm-hmm.
So 5 to the power of 3, 125.
Yeah. And again, for mine, I'm writing. For yours, you can write this because if you have to write it on your piece of paper, but I'm just going to keep doing the way I have it written. So this is
Okay.
3 cubed, which is 27. So that would be my answer. My answer would be 27 comma 0.
Okay.
But your answer would be 125 comma 0, right?
Yeah.
If that was log base 5. Yep. Okay. See how we do that?
Yeah.
Good. Let's do this one a little bit faster. You ready?
Oh yeah, that's also a 5. So can I have it as a 5?
Sure. Yeah. Let's switch that right now. Thank you. So again, log base 5 of x, it really still is the same kind of graph. The shape of the graph is relatively the same. The only difference is that it's a little bit more stretched out than the other one that we were looking at.
Yeah.
Okay. So this one's a little bit trickier because of the negatives on the inside. Now, has your teacher explained to you how to solve for this one?
No.
How to flip or solve or anything like that? There's a couple ways to do it.
Oh no, not yet.
Well, what we can see for sure, let's just talk about what we know for sure, is this is going to do what with it? The 4?
The
It's going to move it
4.
where? Up
Sorry.
4?
The 4 you move it to the left side.
That's going to move it up 4 because it's on the outside,
Oh yeah.
right? What's this 3 going to do?
The 3 is gonna give it a stretch of 3.
Mm-hmm. Very good. It's going to stretch it vertically,
Yeah.
a vertical stretch, which is a horizontal shrink. And what is this stuff in here going to do to it?
There will be a horizontal stretch of -2.
Mm-hmm. Which means a vertical shrink. So they're going to fight each other, right? But it's also flip. It flips and stretches.
Yeah.
And then this right here is a horizontal shift. And I'm not going to say left or right. This is the tough part.
All right.
It's the trick with this is it really it depends on what the sign is right here.
Yeah.
See how there's a negative there? So that actually makes this a negative. You look at that and you think, oh, look, I'm moving it right 1, but you're really not because of the negative here. You're really moving it the opposite direction. And the best way to think about that is just to set this whole thing equal to 0. Okay. So the
Yeah.
way that I like to think of the shift, I don't know if your teachers taught you this, but I like to think of it like this: set that equal to 0 and solve it. So the solution would be x equals -1/2, which means
Yeah.
I'm going left 1/2. Okay. So that's
Yeah.
ultimately what my thing is going to be doing. It's going to be moving left 1/2, but it's also moving up 4 and it's also stretching. So, but here's another way you can do it. This is actually the way I like to do these, to be honest with you. I like to just graph. I like to just use what I was showing you before my X and Y, and I like just picking numbers very carefully to put in to my X's and my Y's.
Yeah.
So I want this whole thing to equal 1. So watch what I'm going to do in my head, or I'll do it on the paper. I want negative 2x minus 1 to equal 1 first.
Yeah.
You understand? So
Yeah.
I want negative 2x to equal 2, which means I want x equal negative 1. So I'm going to put negative 1 in for x. And the reason
Yeah.
I'm doing that is because then I will get a nice whole number out. Right?
Yeah.
My whole number that I get out is going to be, this is going to be 0, right?
Yeah.
And then it shifts up 4.
Yeah.
Got it?
Yeah.
The next thing I'm going to plug in is I don't want that to be 1. Now I want it to be what? Since it's base 5, I want it to be 5.
5. Yeah.
So adding gives me 6, dividing gives me negative 3. So I'm going to plug in negative 3 now. And when I plug in negative 3, I'm going to get 7. You follow?
Yeah.
The next one I'm going to do, instead of 5, is what? What's the next power of 5?
25.
Perfect. Add 1, you get 26. Divide by negative 2, you get negative 13. So there's my next one. And that would have given me a 2 for this mess.
Yeah.
2 times 3 is 6, plus 4 is
Yeah.
10. Does that make sense?
Yeah.
And when I plot those points, it's easier for me to see what this shape actually looks like. Here's negative 1. Whoops. Here's negative 1, comma 4. Here's negative 3, comma 7, 4, 5, 6, 7.
Yeah.
You get what I'm doing?
Yeah.
Did I do that right? Negative 3, comma 7.
Yeah.
So can you see what the shape would? And then it's negative 13, comma 10. So you can see the shape is doing. Where's it going to go to? The shape, which normally would have been this, has flipped. And also, what's the what's the vertical asymptote?
The vertical asymptote is
remember, it's where this thing equals 0.
Oh, okay. So it's negative 2x minus 1 equals
So
0.
yeah, so let me
Plus
show
1.
you that as well.
So it's negative 1/2.
That's right. X equals negative 1/2, which that makes sense, doesn't it?
Yeah.
So there's your vertical asymptote.
Yeah.
X equals negative 1/2. And so my graph, I can see what my graph's going to do just with those points. It's going to go like this. And there's that stretch.
Yeah.
There's that stretch, vertical stretch and the horizontal stretch, really both of them.
Yeah.
Okay, good.
Yeah.
What's the X intercept? Actually, let's do domain. What's the domain? I'll sneak it underneath there on the D. Can you say what the domain is?
The domain is
Remember, I'm thinking, where is it going to touch the axis? Or what vertical lines are going to touch it if I'm scanning from left to right? Yes, 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 yes. No. No, 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 no.
yeah.
So it's from negative infinity to what?
Negative infinity to
It's always the vertical asymptote. Negative 1/2.
infinity to negative 1/2.
Yep. And what's the range?
The range is negative infinity, positive infinity.
Perfect. What's the X-intercept?
The X-intercept is you have to substitute that into 0 equals 3 log 5 of x, negative 2x minus 1 plus 4. So subtract 4 from both sides. You get negative 4 equals 3 log 5 of x. No, I
Then
mean
divide.
negative 2x minus 1. And then you divide both sides by 3. So you get negative 4 over 3 equals log root 5. I mean log base 5 of negative 2x minus 1.
Mm-hmm.
And then you multiply, not multiply.
Convert it. 5 to that power
Oh, all right, okay.
equals negative 2x minus 1. Right?
Yeah,
Now add 1 to both sides.
yeah,
So 5 to the negative 4/3 plus 1 equals negative 2x. Now divide both sides by negative 2.
yeah,
So multiply by negative 1/2 basically. So it's negative 1/2 times 5 to the negative 4/3 minus 1/2. And again, if you want that, you can find the exact answer by just plugging that in your calculator. But
yeah,
if they want, well, you can definitely find it, but you might have to round it. So you can plug that
yeah,
into your calculator very carefully. Negative 0.5 times 5 to the negative 4/3.
yeah,
Hit enter. And then minus 0.5.
yeah,
Negative 0.56 roughly. And that
yeah,
makes sense. Negative 0.56. It's just left of negative 1/2,
yeah,
right? But it's never going to touch that because that's the vertical asymptote. Okay. So do you understand how I did that problem?
yeah,
How I carefully chose my x values?
yeah,
You could have shifted and flipped and all that kind of stuff, but it just gets confusing when you do that, in my opinion. And when
yeah,
you have something like this, when you have something crazy like that, I recommend that you do that little trick that I just showed you. And if you don't do that little trick, just make sure when you're done, you plug in your points and make sure they actually work.
yeah,
Because more times than not, people start doing, okay, let's flip it first over the y-axis, and then let's shift it. Oh wait, hold on, where do I shift it? Not one, right? So then they figure, okay, wait, I have to factor out a -2 first. That's the other way you could have done it. Again, let me show you because your teacher might do it this way. You could have rewritten that as f of x equals 3 log base 5 of, now factor out the -2, and you get x plus 1/2 plus 4. And now you can see, oh yeah, it shifts to the left 1/2, right? But then it
yeah,
also flips and gets stretched horizontally,
yeah,
and it gets stretched vertically, and it gets moved up 4. So if you're going to use the transformations, I would first factor this out so that you have a leading coefficient of 1 with that
yeah,
right there. Make sense?
yeah,
Okay. I feel like this is that same one, isn't it? I don't think I deleted that page.
yeah.
This one new? Is this right? Did I write it correctly, or is it log base 5?
Let me check. 1/2 log base 4 of negative x plus 5.
And again, it doesn't really matter if it's log base 3, 4, or 5 in terms of what the picture looks like. The
Yeah,
points are going to be different, but it really doesn't matter that much. Your picture is still, it goes through the point, the general graph goes through the point 0 or 1,0, and the vertical asymptote is the x-axis, or the y-axis, sorry.
yeah,
So your graph's always going to look roughly like this. The only difference is, does it go through this point, or does it go through this point, or does it go through this point, right? Or that's log base 3, that's, whoops, sorry. I did that wrong. That's log base 3, that's log base 4, and that's log base 5. They're all going to go through this point right here. They're all going to have this asymptote. So it
Yeah.
just matters how stretched out they are.
Yeah.
Follow what I'm saying? That's why
Yeah.
it doesn't really make that big of a difference. Okay, so what does this do? And again, see how we got that little problem there? Let's try
Yeah.
this one that other way that I was just referring to. Let's try doing this that way. So
Yeah.
what did I tell you to do? What should you do to make this easier? Factor out a -1. So this would be x what? If I factored a -1 out, what would
then it
that be?
goes negative x minus 5.
Not negative. Yeah, negative
yeah,
quantity
negative
x
x minus
minus
5.
5. Okay. So then what you could do this. You could shift, you could flip it. Remember when the negative is with the x, then it flips over the y-axis, yes?
Yeah.
So this is going to flip here. It would be here. But then it shifts where?
It shifts
5 to the right.
yeah.
So the vertical asymptote 3, 4, 5 is right here. The vertical asymptote shifts over there. So that point becomes this point right here. And 1/2 means that it goes up. It means it's getting flattened. So let's just make sure, again, like I say, I always want to make sure that that point is correct. That point should be what? 4, 0.
Yeah.
Let's see if 4, 0 worked. See, that didn't work.
Oh, okay.
4, 0 didn't work, so I did that wrong. That's why I prefer to do it the other way. It shouldn't be 4, 0. It should be, oh no, it is 4, 0. My bad. That worked. I was too quick at plugging it in. What's the log, or what's 4 minus 5? That's -1, but then we have a negative of that, so it's +1. What's the log base 4 of +1?
Log base 4
What's the log base anything of 1?
0.
0, and 0 times 1/2 is 0. So that actually did work.
Okay.
And it's going to go this direction, right? So normally it would be over 4 up 1, but because of the 1/2, it's over 4. Sorry, not over 4. Over, that would be right here. Over 4 from the x-axis.
Yeah.
Over 4 up 1, it's over 4 up 1/2. So that should be 1, 1/2. Yep, that's correct. 1, 1/2. What's 1 minus 5? 1 minus 5 is -4. What's -4? It's +4. What's log base 4 of 4?
1.
1. What's 1 times 1/2?
1/2.
1/2. Okay.
Yeah.
The next one would be 16. If I go 16 from this line, 16 places from that line, I would go up. Normally I would go up 2, but now I'm only going up half as much, so I would go up 1. Now I'm not going to waste my time drawing that, but you get the idea. So it's going to go like this. It's going to go like that. And over here, it's going to approach the axis like that, or the asymptote like that.
Yeah.
Okay. Do you get how I did that? Again, my preference, to be honest with you, is just at the very beginning, don't do any of that.
Yeah.
Pick numbers that make this very nice. Pick numbers that make this 1. I want this to equal 1. Then I want it to equal what?
Yeah.
After I equal 1, what's the next power of 4?
Sorry. You get 16.
Do you understand what I'm saying?
Yes.
That's what you want to do. So how does that equal 1? This thing, how does this thing in here equal +1? It equals +1 when x equals 4.
Yeah.
How does it equal 4? It equals 4 when x equals 1.
Yeah.
How does that thing equal 16? That thing equals 16 when x equals -11,
Yeah.
right? So your y value, again, just plug it in. Do you see what I'm talking about, how it's easier? In my mind, if you're following the way I'm thinking, it's easier than even what I did here where I factored that
Yeah.
out and I tried to use the shifting and flipping and all that kind of stuff.
Yeah.
To me, it's just easier to pick those numbers, to hand pick those numbers and make sure I'm doing it right. So when I plug 4 in there, I get 0. When I plug 1 in there, I get 4, log base 4 of 4, which is 1 times
Yeah.
1/2. So that's 1/2. And the next one's just going to be 1.
Yeah.
So I know that at -11, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. That one right there is going to be at 1
Yeah.
right there. That's -11, 1. Okay.
Yeah.
All right. How about this one? Easier or harder?
That one was a little bit. It's like a little bit better, yeah. Oh, this one is
It's
actually
better.
says 2 minus log 3.
Oh, did I write it wrong?
Yeah, it says 2.
2 minus log 3.
Yeah.
Everything else is correct?
Yeah.
Okay. How does this one? What's the first thing I'm going to do?
You have to flip it. Or like not flip it, but you have to like deal with the parentheses.
Deal with the parentheses. Okay. So how am I going to deal with those? By the way, on this last one, are you good with the horizontal asymptote, vertical asymptote, or the
Yeah.
vertical asymptote and the domain and range and X and Y intercepts? You good with those? Or do we have to do that?
It would be better just to kind of work it through. So I can
Yeah,
kind of
let's do the
remember.
Y. The X intercept we can see, right?
Yeah.
There's your X intercept. What's the Y intercept? How do I find it?
Just make x 0.
Good. So f of x equals 1/2 log base 4 of 5.
Yeah.
There you go. That's the answer. 1/2 log base 4 of 5. If you want an exact answer, otherwise you could plug it in and just, do a estimation or approximation.
Yeah.
Okay. Okay. What now? How are we going to do this one? Walk me through it. I'll let you walk me through this.
All right. So we can find the x intercept by setting y equal to 0. So it would be 0 equals 2 minus log base 3 of 3x minus 6.
Okay.
And we can subtract 2 from both sides.
Okay.
-2 equals negative log base 3 of 3x minus 6.
Okay.
And then we can, that would just be 2 equals log base 3 of 3x minus 6. So
Okay. Good job.
3 to the power of 2 equals 3x minus 6.
Good.
So 9 equals 3x minus 6
Mm-hmm.
plus 6 plus 6. 15 equals 3x, x equals 3.
Not 3.
Shoot.
5.
Oh yeah, 5. That's what I meant.
Yeah, I thought you did. Okay, so x equals 5. So that's good. That's one of our points that we're going to want, right? The x equals 5. There's our x. There's our x-intercept. What's our y-intercept?
Y-intercept is 2 minus log base 3 of -6.
And what do you immediately think?
Oh, you need to subtract the -2.
Hold on.
Wait,
Think about the last thing you just said. Log base 3 of what?
-6?
Is that possible?
No,
So I'd say none,
none.
right?
Yeah.
Okay. So remember, the graph normally would look like this. But what does this negative in front of it do?
It flips it upwards.
That's right. It flips it upwards. And then where did this move it? That shifts it. You remember what I told you to do? I said set that equal to 0
All right,
and
yeah.
solve it. So x equals 2, which means that shifts it right to.
Yeah.
That's what it tells you. That tells you to shift it right to. So my vertical asymptote now shifted right to as well.
X equals 2.
You understand that?
Yeah.
That shifted right to. And the 3 in front here, really what that did is it just kind of stretched it out horizontally. So again, if you want to do that smart thing that I was talking about, let's smartly choose our x values so that our y values are nice numbers. Well, we want this to equal 1, which means x would equal, so set that equal to 0. 3x minus 6, I'm sorry, set that equal to 1. So x would equal 7/3. So there's 1 point. And then we want this thing to equal 2, right? So 3, I'm sorry, not 2. We want it to equal 3. 3x minus 6 equals 3, right? Because that's 3 to the first power. You got it?
Yeah.
Which means x equals what?
Sorry.
But I said, remember, you don't have to do this while we're working. You can watch this again later.
Yeah, okay.
So try just to listen and respond to me to make sure you're totally gathering what I'm saying. If I solve this, what do I get? Add 6, I get 9,
You get
divide
9,
by
so you
3.
get x equals 3.
Good. So 3 is my next one. And let's
Okay.
make this thing equal. What's the third thing we want that to equal? Remember, what's the next power of 3? We had 1, we had 3, and what's the next power of 3?
9.
Perfect. So 3x minus 6 equals 9. And if I want that, then x equals 5, right?
Yeah.
So there's the 3 numbers that we wanted to use. So when I plug in 7/3, I get what? That whole thing is just going to
7/3.
equal, what's the log base 3 of 1?
0.
It's 0. So this is just 2.
Yeah.
When I plug in 3, what's this whole thing going to equal when I plug in 3 here? Remember, this whole thing is going to equal 3. What's the
1.
log base 3
So
of 3? So that whole
1.
thing is 1. 2 minus 1 is
1.
1. And how about this one? 5. When I plug in 5 here, that whole thing equals 9. Log base 3 of 9 is
3.
log base 3 of 9 is 2.
Yeah, 2, sorry.
And 2 minus 2 is 0.
All right.
So can we see our points?
Yeah.
So here's 3, 1. We already got this one up here. We already got 5, 0. And what's 7/3 the same as? How many times does 3 go into 7?
2.
And what's left over?
1/3.
Yep. So 2 1/3.
Yeah.
2 1/3, 2. 2 1/3, 2. Do you see what's happening?
Yeah.
Where's that going?
It's going upwards.
Just like we talked about, right?
Yeah.
We knew it had to do this. And what's it doing over here?
It's approaching the Y.
It's not really
X.
approaching, it's just shooting off, right?
Yeah.
That's what our graph is doing.
The middle mean is negative, not negative, positive 2 to infinity. And
Good.
there's negative infinity to infinity is the range.
Perfect. And we already talked about X and Y intercepts, right?
Yeah.
All right. You feeling good about this?
Well, yeah.
Okay. What do you want to do this one again? Oh, now we're trying to find out what this is. Perfect. So now this one is saying what is write the graph or write the function given the graph.
All right.
And what did they say on the graph? Was that 5, negative 3.5? Is that what this is? 5, negative 3.5? Am I reading that
5
right?
negative 3.5, 6 comma negative 4.
Okay.
And then for the Y-intercept, it says 0, negative 3, and 1/64.
Okay. So they're giving us those points. So we want to kind of undo this problem, and you can see, let's see, there's a couple ways you can do this. You know, the equation is going to be, this is a logarithmic or an exponential. Which one is this?
This one is sorry. That looks like a logarithmic.
Nope.
Oh, no, it's an exponential, sorry.
Yep. Hassies have horizontal, I'm sorry, Hassies. Exponentials have horizontal asymptotes,
Yeah.
and logarithmics have vertical asymptotes. That's really the main giveaway. It looks
Yeah.
like one of the two, right?
Yeah.
But because it has a Hasse, we know that it has to be it's going to be an exponential. So the exponentials look like this: y equals a times some base to the x power, and you might be adding or subtracting things as well.
Yeah.
But normally it goes through one away. Normally what happens is it goes through one away from your asymptote. So we can say
Yeah.
we can see that our asymptote is what, -3? Is that what that is? Y equals -3 is the Hasse. And so at -4, it looks like that was, so assuming that A is 1, which it may or may not be, let's just make the assumption that A equals 1. You can see that all we've done basically is shifted this entire graph over
Yeah.
to 6 places. So I think what we're going to do is adding, I'll write this in black up here. I think we're going to subtract 6 from the X on the top. That's my first guess.
Yeah.
So let's see if that's it. Let's see if it's just Y equals, and let's now figure out what that value would be. I'm trying to think of how we would do this. So normally, let's go back to the basic one. Normally it goes, when you go, it goes over 1, up 1, the first point, right? Your normal graph goes through 0, 1, and then you go actually not over 1, up however many it is. So if your base was 3, it would be 1, 3 right there. If your base was 4, it would be 1, 4. You understand?
Yeah.
So what I've done here is, if my that's tricky, those points that they give us are not pretty points, because it almost makes me think that they want us to start here at the 5. But I do you see how this point right here,
Yeah.
the point 6, 4, if I go over 1, I would go up. So this is just actually 2 away from it. So I think the base is 2. My assumption is that the answer is 2 to the x minus 6.
Yeah.
Now we just have to make sure that that's right, or check if it's right.
Yeah.
So if I plugged in 5, oh, I'm sorry, but then we also did what here? We also added what to this? Well, it flipped it upside down. So I'm way off. We flipped it upside down because it normally did this. And we also shifted it down. So I'm going to have to subtract 3. And I'm going to have to flip it upside down, which means to put a negative out in front of it. Does it sound like that might be right? I don't know for sure. Let's find out. So let's plug in the -5. Let's plug in my 5 here and see if it gives me what I want. If I plug in 5, I'm going to get, so f of 5 is going to be -2 to the -1 minus 3. And what's 2 to the -1? That's 1/2, right?
Yeah.
Hey, look what that is, -3.5. Isn't that nice?
Yeah.
So we were right about that. Let's see if we're right about the Y-intercept. How do I find the Y-intercept?
The Y-intercept is,
Plug 0 in for x, right? So it would be -2 to the -6 minus 3. -2 to the -6 is -1 over 2 to the 6th, which is 1 over 3, which is 1 over 32.
yeah.
-3 and 1/32. Isn't that what you said that was? Or is it 64? No, that's 64.
Yeah.
That checks out. Good?
Yeah.
You understand how I did that? That's a little bit of a tricky one. It's kind of hard to find the pattern for doing that, because there's not really, here's the problem. There's too many variables that we can have in here, because all of these can be variables. This can be a variable. This can be a variable. What you're adding and subtracting, the a in front, all of those are variables. So you really only have 3 points. Remember remember systems of equations?
Yeah.
Systems of equations, if you have enough points, if you have 4 variables, you can actually solve a system of equations if you have 4 variables that you have to solve for, as long as you have 4 points to use. We don't have 4 points, so we had to use a different method for doing that. So that was kind of tricky. All right, can I skip this one? This looks like something you could do.
Yeah. All right.
I'm trying to save time because we only have a few minutes left. Tell me what you want to do next. You have some other ones on here, or is that it?
I think I do have some more on here.
Let's try to find another one like what we just did. Do you have one like that?
Let's
Like
see.
where they
There's
give you a picture and we have to work backwards?
actually no. There's only two of them which are like that. Can I just try graphing f of x equals 3 to the power of negative x plus 2?
Sure. Tell me what it was again.
F of x equals 3 to the power of negative x plus 2.
Like that?
Yeah.
Okay. Yeah, good. Yeah, we haven't done these yet. So what are we going to do first?
So first we have to find the horizontal asymptote.
Okay. There's my x-axis. There's my y-axis.
Yeah.
Tell me how I'm going to find the horizontal asymptote. What is it normally?
Normally the in a rational function, it's normally the value multiplied outside over the value multiplied on the denominator. Or no, it's different in rational functions. So
Yeah,
the
you're thinking rational. You're thinking rational functions. It's just the x-axis normally,
yeah, that's right.
right? Normally it does this. So is this shifting at all? Does this -2 or that negative or this 2, does that shift the asymptote at all or no?
Yeah.
Okay, where do you think it shifts it? The answer is actually no, it doesn't shift it,
Yeah.
because this only shifts things horizontally. So moving my horizontal asymptote left and right, it's not gonna affect it,
Yeah.
right? So my horizontal asymptote, my Hasse is still just y equals 0. That's my horizontal asymptote. What is the negative x plus 2? This is that kind of that same thing we were just talking about. You know what I would do? Just to be safe, I would just plug in some numbers here. Let's just see what happens when we plug in 0. What's 3 to the negative 0 plus 2 equal?
Yeah, that would just be 3 to the power of 2.
Which is
9.
good. Let's try 1 now. What's 3 to the negative 1 plus 2?
3.
Good. Now let's try 2. What's 3 to the negative 2 plus 2?
Okay, 3 to the negative 2 plus 2 is just the 3 to the power of 0, which is 1.
There's your point. 2 comma 1 is that point.
All right.
There's your point. There's your handle. And what is it doing? It goes 1, 3, 0, 9. Up there. What do you think it's going to be doing?
It's gonna start approaching the X intercept on the other side.
That's right. That's really what's happening. You understand that?
Yeah.
So what's my so if I keep plugging bigger numbers in here, it's going to get closer and closer to 0 but never get to 0. Right?
Yeah.
Plugging in 4, it's going to be 1/9, etc.
Yeah.
But how about plugging in a negative number? What is a negative number going to do?
It's gonna
It's
become
going to
a
become
positive.
yeah, it's going to become a bigger exponent. Do you see what's happening?
Yeah.
So really what happened here is, look at the graph. That flipped it. Normally it would have gone this way, but now it flipped it this way. But this shifted it. This right here shifted it. Normally you would say 2 to the left, wouldn't you? Because it's the
Yeah.
plus, but remember I told you about when that's a negative there, it kind of changes where it goes. Set this thing equal to 0, and you'll see, oh, that's shifting it to the right too. Got what I'm saying? So this actually shifted it to the right too, and then it flipped it. Okay.